this is what the graph should look like. Okay, if n sub x, in other words, remember we said we have to specify two quantum numbers, n sub x and n sub y. By specifying the value of n sub x and n sub y, you are specifying what the wave function is. Okay, so n sub x, n sub y equals, if both of them are 1, this is the graph that you'll see. This is a contour plot. Imagine this plus right here, that's the peak of your function. So if you were to do, okay, this is your, if this was your x-axis and that was your y-axis, all right, if you were to plot n equals 1, what would it look like? Big X versus little x. From 0 to L1, it would look like that. Remember, it's half a sine wave. And the function y from 0 to L2 would also be half a sine wave. So they're both positive. So all of these numbers are positives. Each of these contour line right here represents all points that have the same value of psi. Okay, so this is a contour representation of the function. So imagine that you have that plus right there. That's the peak at x over 2, at L1 over 2. Okay, you have the maximum value for, so this is L1 over 2, and at L2 over 2, you have the maximum value for the function x and function y, and so that's where your psi is at a maximum. Okay, so that's the representation for n sub x equals 1 and n sub y equals 1. If you were to do a 3-dimensional plot of that, that's just going to look like a mountain. Okay. What if n sub x equals 1 and n sub y equals 2? What would the plot look like? Well, let's see. N sub x equals 1, 0 to L1 is going to look like that, right? N sub x equals 1. And then the function y versus y from 0 to L2. If n sub y equals 2, how many nodes do you have there? 1 node. Remember, you have 1 full sine wave there. So what would happen if you multiply this x and that y together? What would you get? Okay. Sorry. What between y equals 0 and L2 over 2, you have a positive value, right? And between y over 2, L over 2 and L2 over 2 and L2, you have a negative value. So you have positive times positive would give you a positive value for psi. Positive times negative would give you a negative value for psi. And the L2 over 2 value for y would be a node. Okay, so if you draw contour plots for that, so if this is your x-axis, there is no node along the x-axis. If this is your y-axis, L over 2 is right here. Okay, L2 over 2, this is L2, and this is 0. Okay, the plane defined by y equals L2 over 2 is a node. This is not oriented the right way. Let's redo that. Sorry. Okay. Apparently it's set up this way. Okay, so if that's your x-axis and that's your y-axis. Okay, so this is L2 and this is L1. All right. At y equals L2 over 2, you have a node. So this thing right here is a node. Notice your wave function crosses over. It's positive on one side of the node, it's negative on the other side of the node. So you can imagine this plus right here as representing the top of a mountain, and that negative sign right there. So the wave function here is negative on this side. Each of these contours represent points where psi has the same value. Okay, so that bottom of the well right there is in the middle of that half of the box. Okay. So that's what that plot would look like. So this is n sub x equals 1, n sub y equals 2. All right. Let's take a look at this graph right here, this representation right here. What is this? So if this is your x-axis, so that's L1, and that's your y-axis, so that's L2 right there. What do you see here? You have a node right here. You have a node at x equals L1 over 2. You have one node. So this means that n sub x is equal to 2. Okay, remember, number of nodes is just n minus 1. And you don't have a node along the y-axis, so that means n sub y would be equal to 1. All right. So if I were to ask you, if I were to give you this graph right here, this plot, and I ask you to write the wave function, what would it be? You're going to say that that's equal to, that psi, as a function of x and y, is going to be square root of 2 over L1 sine, what's n sub x here? 2, so 2 pi x over L times square root of 2 over L times sine, and what's n sub y? It's 1, so it's 1 pi x over L. Okay, and this is L1 and that's L2. All right. So that's your psi. That's the psi for this one right here. What would be the psi for this figure on the right here? What's our, for this one right here, what's our n sub x? N sub x is 2, n sub y is going to be 2. Okay, so you can see every time you cross a node, your wave function changes sign from positive to negative to positive to negative. Okay, so you have two nodes here. One node at L2 over 2, the other node at L1 over 2. X equals L1 over 2. Okay, so let's do contour plots for n sub x equals 3 and n sub y equals 4. Let's do this. So you're gonna go from 0 to L1, right, along the x-axis. How many nodes do we have here for n sub x equals 3? 2 nodes, right? So we're gonna divide this into 3 segments. So here's a node, and here's another node, and then we're gonna go from 0 to L2. How many nodes for n sub y equals 4? 3 nodes, right? So 1, 2, 3 nodes. So this is L1 over 3, and this is 2L1 over 3. This is L2 over 4. This is L2 over 2, and this is L2 over 4. Okay, so those are your nodes. That's a node. That's a node. That's a node. That's a node. And that's actually the edge of the box, so that's 0. So you have 3 nodes. 1, 2, 3 nodes along the y-axis, and 3 nodes along the x-axis. 2 nodes on the x-axis, right? So those are nodal planes, actually. No, that's not nodal planes. Nodal lines. Okay. So what's the sign of your wave function going to be? What does the wave function look here? Along the x-axis is going to look like what? It's going to look like positive, negative, positive, right? So it's positive here, negative here, positive here. Along the y-axis, what are the algebraic signs of your wave functions? Starts off positive and then negative, positive, negative, right? So positive, negative, positive, negative. So if you multiply a positive factor and another positive factor, what's it going to be here? Positive here. Negative times positive, it's negative here, right? Positive times positive, over here is going to be positive. So as you cross nodes, basically, the idea is when you cross over a node, you just change algebraic sign of your wave function. So if you were to draw contour plots, you would have contour plots like that. You'd have the maximum value in the middle of these compartments, right? And so you're just going from positive here to negative here. So this thing right here would be the bottom of a well. This thing right here would be the top of a mountain. Okay? So imagine you're looking at it from the top and you're cutting slices of at equal heights and trace the edges of those slices. You get your contours.